Now, we want to look at that college admissions officer's um, example we were working on. Now, instead of doing a hypothesis test, though, we want to estimate the proportion of all college admissions officers who look up information on applicants' Facebook and social media page. The first step is to verify the normal approximation is valid here. If you're not told it's valid, you need to do the testing. So please pause the video and verify that you can use the normal approximation here. You're going to note that I said recall that n equals 364 and p hat equals 0.25. Remember, we're looking at constructing a confidence interval here. So are we going to do n times p or n times p hat? Please pause the video and verify that the normal approximation is valid. So things you should have checked were the population, that 10% rule. In other words, that the population is at least 10 to 20 times the size of the sample. And there are more than, we can say confidently, there are more than 3,640 college admissions officers in the group that we're looking at, in the population we're looking at, I should say. And two, n times p hat and n times 1 minus p hat are both at least 10. So we want to draw a conclusion here. We don't want to just do the two steps and say, and be done. We want to then say, well, the normal approximation is valid. The next thing we want to do is come up with the confidence interval. Remember, we want the 95% confidence interval. That's the only one we've discussed how to construct at this point. We're going to take p hat plus or minus 1.96 times. Remember, so here's where we're going to center. And this is that standard deviation. So this will construct a 95% confidence interval. This is to account for sample-to-sample variability, because remember, you're like, why can't we just say it's 25%? Remember, samples vary. So then we're going to plug in the numbers. And you're going to get 0.25 plus or minus 0.044. When we construct this interval, we're first of all we always want to make sure we go from small to large values. So there is that 95% confidence interval. We're 95% confident that the true population proportion is going to be somewhere between 0.206 and 0.294. Now we need to interpret the interval in the context of the study. Based on what I just said, pause for a minute and think about it. What am I saying? So interpreting the interval in the context, like we do when we look at the conclusion, when we do hypothesis testing, we'd also want to wrap up and tell what we found. And we're 95% confident, that's our level of confidence, that the proportion of all college admissions officers who have looked up applicants' social media page, so we're giving the context, is between 0.206 and 0.294. You could also change that to, instead of proportion, to percent. If I did percent, what I'd want to do is, oops, sorry about that, is change this word to percent, the proportion here, and do 20.6% and 29.4%. So just be consistent. If you use percent here, make sure you list your confidence interval as percent. If you do proportion, use proportions. Now, please take a moment and complete this example and then come back and check your answer. So here we are back at the cyberbullying example. It's continued. Please take a moment and check your work and make sure that you ended up with the same values I did and the same conclusion, same interpretation. Now, are we always going to do the 95% confidence interval? No. But here is a box, important, how you can, the formula and Z stars to compute something other than the 95% confidence interval. So you can do the 90% confidence interval. So are we more confident than 95% or less confident at 90? Well, we're less confident at 90, and so we're going to multiply by a smaller, it's going to be less inclusive. Okay, whoops, sorry about that. Because we're multiplying here by a smaller value. And then we can go up to the 95% confidence interval. These are the values that I would expect you to be able to use on a midterm or on a quiz. If I said 80% confidence interval, would you expect it to be a smaller number than 1.645 or a larger number? And hopefully you think right away, oh, it would have to be smaller because we want to be even less confident than we were before. Now here it says estimate the confidence with 99% confidence the proportion of all such US teens who have experienced cyberbullying. It's going to be the exact same formula. The only thing that's going to change is this coefficient here, the 2.576 instead of 1.96. And we'll end up with 0.543 to 0.635. So this is going to lead us to a wider interval, right? We're multiplying by a larger number, so a larger number times this is going to end up with a larger number. Now, the 99% confidence interval is wider because we're multiplying by a large number. So it's more inclusive. It may not be quite as informative as the 95 because it's going to include more values overall. Now let's talk about what we know. Valid or invalid for these confidence intervals. So true or false, effectively. 99% of all US teens will fall in this interval, 0.543 to 0.636. If it helps, make sure you go back and look at the basic interpretation. Well, this is an invalid statement. It doesn't mention, get that back out, it does not mention the proportion of interest. It doesn't say what we're comparing this to. So not valid. We're 95%, 99% confidence for D, that the proportion of the 743 US teens surveyed who have experienced one or more types of cyberbullying is in this interval. Well, no, this is, remember, we're interested in estimating the population. This is referring back to the sample, so invalid. 99% of the time for E, the proportion of all US teens in 2018 who has experienced one or more types of cyberbullying will fall in this interval. We're not talking about percent of the time, we're talking about level of confidence. So percent of the time, no, 99% confident. So once again, this is invalid. We're talking about confidence or chance or probability. We're not talking percent of time. F. 99% of all US teens in 2018 have experienced between 0.543 and 0.636 incidents of cyberbullying. Well, we didn't count. We're talking here about proportion of incidents versus number of incidents. So this is invalid. Finally, we are 99% sure. More technical word would be confident. Between 54.3 and 63.6 of all percent of all US teens in 2018 have experienced cyberbullying. That looks good to me. We're talking about our level of confidence. We reported the percentages. We're talking about the population, not about the sample. And we put it in context. So that one looks good. So how would I, if I was on an exam, how would I do these? I would personally, once again, take a quick second if I had a general problem, write up the full interpretation and then compare and see what I'm missing or what's different or what's wrong. Let's finish these last two here. A 90% confidence interval based on the same data will be wider than 99. Well, we've already talked about that. It's actually going to be narrower because you're multiplying by a smaller number. Okay, and remember, this is what determines the width of that confidence interval. And finally, if the data from the study had been such that 59% out of a thousand US teens, so the number went up of US teens, then the 99% confidence interval would be wider than that found in B. Well, here's what I would say. I would take a moment and say, well, wait a minute. I'm not really sure. I don't even know where to start with this. What's changed is N, because remember, N before was 743, and now we're looking at 1,000. So this number went up. What happens when you divide by a larger number? Well, it's going to make this whole value smaller. So it's actually going to be narrower, right? Because this is going to be a smaller number overall. So that is invalid.